Um, okay. Hi, everyone. Nice to meet you all. My name is Amel, and I am a research engineer at Ansadib. Ansadib is a company which was created actually by Zohra and Karim Gir. It was founded in Tunisia. It started from Tunisia. Our headquarters right now are in London. We have like offices in Paris, Cape Town, Dubai, and of course Tunisia. And we have also an office in Lagos. So we basically what we do is we try to expand like the knowledge in machine learning, and we have like kind of like projects that we have using machine learning, reinforcement learning. It can be in energy, it can be in any bioengineering and any kind of application. So I'm also a Google developer expert in machine learning, and today what we were going to talk about is AI and climate change. So basically, before starting, every one of us is aware about the climate change that we have today. So just going to be more or less trying to do every stuff that we need to do about it. So while we talk about it, actually, it's just something that we I believe it's something that we need to do something about it, because there is a lot of things that exist in when we say climate change. Lots of things come to mind. It's a very basic topic. Well, for us in Tunisia, we used to have like this topic in high school, at high school, college, and all these kind of things. And it's really people don't understand the importance of it, especially when we talk about it nowadays. And machine learning can be used towards climate change. It can be used, for example, we will talk about some of the applications that can be used with machine learning that we can talk about to help like avoid or like reduce the bad things that the climate change is doing nowadays. Yeah. So one thing also is really important to talk about for the climate change is that it's not something that information is that should be not machine learning is going to solve the problem. So it's not something that machine learning is going to will help us avoid the climate change. It will help reduce it, but if humans don't act about it or don't try to act upon it, won't do anything about it. So this is just a very light presentation, very light, about climate change and how can we use machine learning to reduce the or to detect things that can help leverage or reduce the amount of climate change that we see nowadays. So basically, when we talk about climate change, there is lots of events. One of them, like for example, extreme events, which we can, for example, try to detect or predict using machine learning, but it's not very let's say very easy to tackle, because extreme events are very rare by nature. And when we say extreme, it means that they are rare. And rare events are not something, it's like out of the distribution of the data that we have. So I'm not sure if there are any questions or something like that, or okay. So yeah. And then there is the biodiversity loss that we see every day now and then. The biodiversity loss is, for example, the last rhino that was dead in 2018 in Sudan. And it's like this biodiversity can, for example, lead to, let's say, lots of environmental or loss, and this environmental loss can like affect other things later on. There is also the natural disasters that we talk about. Natural disasters, every one of us have heard what happened lately in China, the floods in Germany also. We saw lots of terrifying, let's say, like the fires that existed in, for example, USA lately. There is lots of natural disasters, and these natural disasters depends on the region actually, and using machine learning perhaps we will try to help us perhaps see the whole global model, because when we say machine learning, is we try to detect when something bad is going to happen after all, using for the climate, this kind of problem which is climate change. There is also the water scarcity, and when we talk about water scarcity, for me, I believe one of the issues and one of the next wars will be probably about water, because the ones who will develop technologies and everything to have more portable water will be able to live longer than everybody else. And as you can see in this like photo, the temperature change in the last 50 years. Okay, I think it just stopped, right? Hello? Okay, cool. So basically, okay. So there is a recent paper that reviewed that the climate change directly fostered a favorable environment for many bat species to thrive. It means if for example, there is hotter, we have like hotter weathers, these weathers can be help these bat species to thrive and exist in our world. Meaning that allowing the emergence of the novel coronavirus, including the SARS-CoV-2 strain. And this is just an example of a climate change, actually. We also, all these images of fires, floods, and all these catastrophics happening for the climate change that happened lately. Okay, cool. So one of the things that is also perhaps interesting to talk about, as I said, the goal is to talk about AI and climate change and how we can leverage this. But before we start, this was taken actually from taking climate change with machine learning, tackling climate change with machine learning paper. Actually, this paper was done by Google's DeepMind and Google. And Google's DeepMind, I think there is Demis Hassib, the CEO, and also Yoshua Bengio, who is from Google AI. There is, if I'm not mistaken, Andrew Ng also, who was part of this paper, who talked about climate change and how we can tackle climate change, different kind of aspects that they have talked about. I will try to have like 2 or 3 parts of them, but not the whole paper out of it. There is also the NeurNeps workshop tutorial, which was in 2014 about climate change. So before we start talking about this, there's something which is, I think, really important, as I said in the start of the presentation, which is actually like there is many array of actions where machine learning is inapplicable. So it means that even though there are lots of great applications of machine learning for climate change, but there are some areas that machine learning won't be a solution. And we omit this entirely. So this is in the paper that I have talked about. So technology alone is not enough. Technology that would address climate change have been available for years, but have largely not been adopted at scale by society. while we hope that machine learning will be useful in reducing the costs associated with climate action, humanity also must decide to act. So it's like, yeah, there are machine learning applications that can be used, but if the humans and humanity will not decide to act, nothing will happen, more or less. So AI can shed light on climate change, and it can help in achieving reducing somehow some of the parts of when we see a climate change. So there is a scientific consensus on climate change, but there is climate change actually. But there is still remaining some uncertainties and some certain things that we are not very sure about. But one of the things is something really interesting to talk about, how climate change affects extreme events, for example. So there has been like global warming, for example. Like, for example, it makes a difference, the change in the air temperature compared, for example, from 1986 to 2006. If we see, for example, in 1996, for Lagos, it was 1.5, now it's 2.5. In Delhi, it's 1.7. Now it's 3.0, which is, there is a huge gap. We totally know that, for example, in China and India, global warming is very affected because of the gas, the CO2 emission, and that we can see actually from the air, from the air in there. There are different other, for example, Stockholm went from 2.7 to 4.1, which is like a huge difference. So it's like the world is warmer in a certain way. And we can see also...
Sorry for interrupting.
Yes.
Can you share your screen?
Hello? Oh, you're not seeing my screen?
Yes, we sent on the chat.
Oh, sorry, I didn't see it. I can't share my screen. Okay, there is a tab. Yeah, sorry about this. Yeah, I think you can, yeah, okay, I think it stopped for a while. Sorry about that. You can see it, I hope. Okay. Okay, cool. So basically, as I said, this is the difference. As I said, here we see lots of global warming right now in 2006 compared to 1986. This is in 2006. I just don't want to know what's like in 2021. So, and this is taken from The Economist, by the way. There is also the shift in the mean. So basically, we have like extreme heat events are more frequent. So basically, the normal is just a zero-based kind of distribution, like a very Gaussian distribution. But right now, this Gaussian distribution has shifted to an average of one, which is kind of interesting and kind of very let's say fearful, because I mean, this is just 1 degree for us, but if we try to compare it, it's like comparing 1 year to 1,000 years for humans, and there is a very huge difference. So 1 degree can literally, I mean, sell things apart or fell things apart, and can change a lot of things in the climate nowadays. So when we say uncertainty in extremes, we say especially in regional parts. So we have, like, for example, warmer atmosphere can hold more water vapor. Like, it means that we have heavier precipitation. Like, it can lead to storms also and flooding. And there is also the global warming may increase surface evaporation, like heat waves and droughts. And this is something really interesting to talk about. But extreme events are rare by definition. So the climate may change affect their distribution. When we say distribution, let's talk about AI in general. When we talk about AI, there is the model that we have and there is the data that we have. If we have a data distribution and we have extreme events, these events can vary from one data to another or from one distribution to another. So the climate change may affect the distribution of the data that we already have, and it's very hard to predict what's going to happen using AI, especially for the climate. When we talk about weather, there is a difference between weather and climate, actually. So climate is like for a big period, and weather is for a small period. We're very capable of doing the prediction of the weather using machine learning, because it's on the small range of small area or a small range of data, but it's very hard to do this for the climate change in general, because there are the extreme events, and these events are very rare. What we want to do is to basically machine learning is you try to do to generalize using the distribution that you have. But if what you're going to try to do is to try to detect the extreme events, it's very hard to do this using machine learning. And that's one of the things why sometimes machine learning can be harder to be used, for example, in this kind of things. Another thing which is important to say when we talk about data is that past statistics are not sufficient for future predictions. It means these statistics are not enough. We just need more information about for future predictions for these kind of events, because as I said, small rare event, extreme event means rare event. It's very hard to talk about this. So what's the type of data that we can use, for example, in the climate change for AI in general? So we have like 3 types of data. The first one is the past, which is the historical data, which is actually a very limited amount and very heterogeneous. It means that there are not very much information about it, and it's not very we can't use it in a way that a machine learning model can be able to predict what is going to happen later. There is also the present part, which is the observation data, increasingly measured, which is what we are trying to do nowadays. We try to detect everything using sensors, using what we have to create, for example, images, satellite images. It can be also like listening devices and all these kind of things for climate change. So actually, when we can say increasingly measured, it means that, but most of them are unlabeled. And when we say unlabeled data, is that you have the data, but you don't have what it does mean corresponding to feed it to your machine learning model. It's sparse, also measured at higher resolution. There is also the past, present, future combined together, which is the climate change simulation future predictions can be validated, because some information is lost in discretization. I mean, how we can use the climate change simulations to be able to use some information that we have, even though it's diacretized in a way or in another for future predictions. Okay, so how to tackle all of this? How to tackle the problem of climate change using AI? This part we will talk about the carbon emission and capture, for example, capturing or reduction of the carbon emission. So one of the interesting things is that the IPCC, which is the Intergovernmental Panel on Climate Change, estimated that within 13 years the world would be facing catastrophic consequences if we don't limit and severely reduce global greenhouse gas emission. One of the applications that we can do using machine learning is how to reduce this global greenhouse emission. One of the things is that we are very still far away of this, because actually what we want to do is we want to basically try to achieve what's called zero net emission. And zero net emission is like zero emission of the greenhouse, and it means that we don't have a greenhouse effect later on. And this is the goal of what we are trying to do for 13 years, but we are very still far away from that. One of the techniques that can be used is natural or semi-natural methods, because basically global emission is rising, but deforestation is adding fuel. So it's like we're having global emission, and we have deforestation, which are two things. If you can stop, like for example, global emission, but at least let's try to detect using machine learning where deforestation is happening and how to avoid deforestation, and perhaps try to achieve a reforestation later on. So basically, if we try to reduce the amount of deforestation, it can for somehow help in reducing this global emission with this. So basically, deforestation per year is 18.7 million acres. So what we can do using machine learning, and this is an application that they have talked about in the paper, as I said, this is part of the paper tackling climate change using machine learning. So basically tackling the deforestation using satellite images, differentiating the cutting of selective cutting, or the selective cutting, and detect the chainsaw sounds within a radius of 1 kilometer and report this. So basically, what's the thing is that if we have your satellite images and you have, for example, a video or a machine that is able to detect, for example, if something is happening. Let's say we have a satellite images, and in this image you can see the before and after. You can detect if a deforestation happened before in these satellite images with a basic, like for example, computer vision kind of applications. For example, object detection or semantic segmentation basically helps for this kind of applications. There is also detect the chainsaw sound within a radius of 1 kilometer. So one of the interesting things is that AI can detect these kind of sounds, and these chain sounds can be detected. And if you can detect it, you can report. And if you can report it, it can, for example, stop people, for example, who are doing this illegally in a way or in another. So there is also, as I said, the reforestation part, which we can use, for example, to help reduce the carbon emission kind of part. There is also another technique that we can use for using machine learning, which is sequestering CO2. Sequestering CO2 is like basically we have a reservoir, as you know, everyone knows, we have reservoirs for gas and oils. For example, under the land, we can have a reservoirs for CO2, and that's the whole part about it, the whole idea about it actually. So basically what we try to do is we capture the CO2, and it must then later on be sequestered. So it's like a reservoir of CO2. So what we can do is something like this, subsurface imaging based on semi-graph traces to find extraction points. Machine learning can be used to help identify potential storage location. It's like one of the techniques used in machine learning for the oil and gas is to try to find the points where there are oil and gas using machine learning from subsurface images, the CT scans, for example. And from these CT scans, for example, on seismograph traces, you can find information about, for example, fossils, about information about lots of things in the land. And using machine learning, you can detect these kind of fossils or these kind of lands. So basically what we try to do is that we try to inject the CO2 in reservoirs in places that can be used, for example, for this kind of purpose, in contrast to extracting the oil and the gas part that we have. So basically one of the kind of application is that using convolution image-to-image regression techniques for uncertainty quantification in global CO2 storage simulation. So it's like a CO2 storage, it's a simulation of the CO2 storage that we can use using convolutional networks, something like that. There is also another application, which is climate prediction. So basically what we can do is that uniting data, machine learning, and climate science, which is basically what we can say is that we have data, but how to model the systems using traditional statistics. But also good models, we have also good models, but they're very computationally expensive to use in production. The goal is to use the data, machine learning, and climate science together to help achieve the climate predictions that we can do. So machine learning can be used to calibrate, for example, satellite sensors, classify crop covers, identify pollutant sources that we have, for example, in images, in any kind of things that we can use using for machine learning. So one of the things that it can be also interesting is that using deep neural networks, which is part of the machine learning, when we say a machine learning, using thermodynamics. And what we try to do is model the uncertainty, for example, for clouds ice sheet and sea level rise. So what we try to do is we try to predict if something is going to happen in these kind of things and this kind of uncertainty using models like machine learning. And this is machine learning is somehow less complex than the typical examples, or let's say typical kind of applications that they were used before for climate predictions. And it's very hard to use them, as I said, more intensively because they are computationally expensive. So, for example, we can say like bright clouds reflect light and help cool the earth, while dark clouds absorb the light and keep the earth warm. So if we know this kind of information, we can model the uncertainty and say how we can achieve a better model using this kind of deep neural networks and this kind of thermodynamics, as I said, knowledge about it. So this is, for example, the global average sea level change. For example, in 1880, it's basically it was 0%, or let's say the sea level was 0. But right now in 2016, it's like an 8 or 10 somehow level, which is very huge in comparison. Compared to the previous century. So there is another application which is forecasting extreme events. And this is important, as I said, because extreme events are very rare by nature. And it means that what we try to do is we try to predict this kind of extreme event, it's perhaps in a way to stop them or preventing them from happening, like floods or I don't know, let's say a fire or anything like that. So there's, as I said, there is a very big difference between weather and climate, which is climate is what you expect and weather is what you get. So basically weather can change within few minutes or hours, but the climate takes very long time to change. And the weather models actually are far more easier and more accurate to produce than the climate models. So basically, as I said, the weather, we have the information right now, for example, about last week, or it can be yesterday, and we can predict from them what's going to be the weather like today or tomorrow, something like that. So it's very accurate, and it can be used in production. But the weather, as I said, is short-term. Models are tested and updated every day to accurately predict short-term weather conditions. But it's not the case for the climate, which is extreme events are very rare, and it's very hard to predict what's going to happen after all. This is some parts of that the paper have talked about. This is not everything. There's lots of other applications that can be used, for example, using machine learning. And I really encourage you, if you're more interested to know about all these kind of things, to look for that paper. Yeah, I think that's all from my side. I think I didn't pass my time. I'm not sure if any one of you has any kind of question or anything. Okay. No questions? Okay, if you want to learn AI, where to start? Okay, I think the best way to learn AI things that are really interesting. Talk about the deep learning book. I will share this deep learning. You can find online. It was by Ian Gutfellow. Gutfellow is someone who wrote, was actually at Google, but yeah, deeplearning.ai is a good one too. But I think deep learning book is a great one, especially if you want to learn about the mathematics behind machine learning. And it really captures all the details about machine learning, from where to get from the data, distribution, optimization, regularization, and all the things that exist for machine learning. And it's really good because one of the things that and GANs are really used to generate images and can be used in different kind of applications nowadays. So the book is really interesting. Ian Goodfellow, as I said, was at Google, but right now he's the head of machine learning at Apple. And it's also, I think, was written by Yoshua Benju. Twitter is a great place actually to learn more about machine learning. If you're interested, try to follow there are lots of amazing people out there. I don't know, there is Jan LeCun, who is from Facebook. There is also, let's say, there are lots of people actually, but that are more or less interesting. Deep learning .ai is really great. The specialization of Andrew and Jay is really interesting. And if you're more interested to know about all the details of machine learning and how to start with applications and all of these kind of things, is really interesting. Coursera, you can find this on Coursera, or you can find it on YouTube if you're interested. There is also the financial aid that you can apply for if you don't have like access to, I don't know, to pay or anything like that. Yeah, I think there is also good places like, let me remember it. What's its name? Yeah, totally forgot about it. But I think one of the good resources is the Deep Learning book by Ian Goodfellow. Andrew NJ specialization. As I said, there is Twitter. There is what I can think about. Yeah, I totally forgot what its name, but I think it was by Jeremy Howard. Yeah, OpenAI is a good place. OpenAI is like, yeah, Hugging Face. You can look at the Hugging Face kind of tutorials if you're more interested in natural language processing. Jeremy Howard, if you're more, yeah, Fast.ai. I forgot about it. Fast.ai, it's like it gives you very natural and intuitive examples, and when you're coding all the things, it uses PyTorch actually. There is also the TensorFlow.org that there if you're more interested to know how to use there is also the crash course of Google Crash Course. I think that's it, if I'm not mistaken. There is also computer vision kind of interesting, very interesting part, which is, I think I have it somewhere. You can computer vision without a PhD. A PhD by Martin Gorner, if I'm not mistaken by the name. I think it's a good explanation of the computer vision. If you're more interested about RL, I really recommend the David Silver. You can find it course. David Silver by Google DeepMind, if you're interested in reinforcement learning. Sorry about that. Silver. Yeah, David Silver. I think that's all. Yeah. If you're more interested to know how to learn machine learning and all this kind of thing, I think these are the things that I've tried, started using it. When I started machine learning. I'm not sure if there are any other things. I think this is really, yeah, TensorFlow by George, Crash Course. I think that's it. The deeplearning.ai is a good place. As I said, the specialization, which is machine learning specialization, or I forgot its name, but I think there is a specialization, different specialization, but the basic one, it's very popular. So basically, if you say Andrew NJ specialization, you will get it, which is the basic one related to machine learning. You'll understand everything related to classification, regressions, and starting from these kind of predictive kind of models. And something perhaps really interesting to say is that there are different kind of applications in machine learning and different kind of fields. So it's like, it depends whether you're more interested in reinforcement for learning or natural language processing, computer vision, or anything like that. So try to see a bit of all of them and try to decide which one you're favor for. But it doesn't mean that you should like stick to one thing, just doing one thing. Yeah, this is what I believe is best. A machine learning job generally, for me, for example, I'm a research engineer, so I do both of a bit of research and a bit of engineering. The bit of engineering is, as I said, you can learn it using, for example, all these kind of details. For example, using the OpenAI, let's say the Jeremy Howard Fast.ai and Fast.ai, TensorFlow, or Crash Course. I think it's really important to say that if you're interested in machine learning, try to do projects alone and showcase it in your resume or your CV. So basically what you try to do is you do applications and you put them on your GitHub or something like that. So having a better knowledge about the mathematics in machine learning, how machine learning works, for example, the different terminology, yeah, all this kind of thing. So it's like a bit of research and a bit of engineering. Researching means like you need to read papers. You need to have to read papers that exist in arXiv, for example, to be up to date. There is a good, actually, papers with code that showcase the best papers that exist, and you can have a code for them. So papers with code that you can find online can give you by categories, which are, for example, if you're interested in computer vision application, if it's, for example, semantic segmentation, what's the best model, if there is an implementation about it, and you can find the paper related to it. So it's like a bit of both worlds, doing research and doing machine learning and doing some engineering. I'm not sure about other kind of types. I'm sure there is like data scientists who are more likely for, as I believe, are more like for predictive analytics. If you're more interested to know about forecastings for, like, say, I don't know, not typical kind of applications, but finance kind of applications. So basically, you can learn more about data science kind of things, like using, for example, XGBoost, models like GDM, XGBoost, and yeah, like XGBoost, like GBM, I think, decision trees, and all these kind of things. But I think it's really interesting to start from those and then try to see the other kind of applications. There is also research scientists. Research scientists are more people who are with PhD. So if you're more interested to do all of the research that you think about, you're not more into coding and all these kind of things, you can find, like, for example, do a PhD. And then, for example, in, I don't know, there are different kind of PhDs actually that you can think about or try to find, and then try to find a machine learning kind of, for example, internship there, and then trying to work in kind of these kind of applications. So yeah, if I try to summarize it, I think there's also the part of doing machine learning in production, which is trying to have your model and put it in a backend as and opposed to your front end, which is a kind of applications. For example, it can be anything. So yeah, I think that summarizes it a little bit about it. So it's like a machine learning engineer. This is a machine learning engineer if you try to have the name, the full name about it. So there are different categories. So it depends where we want to go and where you want to work in, and all these kind of details. So yeah.
Okay, thank you, Amal, very much for this great presentation and for your Q&A answer.
Cool, great, thank you very much for the invitation. I hope it was insightful and fruitful. See you next time, hopefully, inshallah. Bye-bye.
Yes, sure. Thank you a lot again.
Thank you, bye-bye.
Bye-bye. Have a nice day.
Have a nice day.